The problem statement in question 18 is as follows. The sum of the 4th and 8th terms of an AP is 24. The sum of the 4th and 8th terms is 24. And the sum of the 6th and 10th terms is 44. And we have to find the first 3 terms of the AP, which basically means we have to determine the AP or its parameters A and D, the first term and the common difference, because that will enable us to write the first 3 terms of the AP. So we have to find the unknowns are the first term, which let's take it as A, and the common difference, let's take it as D. So the unknowns are A and D. We have to find these unknowns and then we have to determine the first 3 terms of the AP. Now the 2 pieces of information that are given to us, the first one is 4th and 8th terms, their sum is 24. So we can write this as T4, the 4th term, plus T8, the 8th term, is equal to 24. And we are also told that the sum of the 6th and 10th terms, so T6 plus T10, this is equal to 44. Now what we will do is we will write each of these 4 terms in terms of A and D, and we will make use of the formula Tn, or the nth term is A plus n minus 1 D. So let's do that. So let's take this equation 4 first. T4 plus T8 is 24. So what is T4 in terms of A and D? So T4 is A plus n minus 1. So n minus 1 is 3. So A plus 3D. This is T4. And T8, which is the second term, is A plus 7D. N minus 1 is 7 for the 8th term. So A plus 3D plus A plus 7D is equal to 24. And to make sure that you're clear, A plus 3D is T4 and A plus 7D is T8. And this gives us a linear equation in A and D. So what is that linear equation? 2A, A and A is 2A, and 3D plus 7D is 10D. So 2A plus 10D is 24. And if I take out the common factor of 2 from the left hand side, divide it on the right side, I get A plus 5D is equal to 12. So this is the first equation in A and D, and similarly we'll get another equation using this second equation. So let's write that. So T6 is A plus 5D because n minus 1 is 5, and then T10, the second term, is A plus 9D. This should be equal to 44. And A plus 5D is T6, A plus 9D is T10. Okay, now this will again give us another linear equation in A and D. So we have A and A, that's 2A, and we have 5D plus 9D, that's 14D. This is equal to 44, and dividing by 2 on both sides, we get A plus 7D is equal to 22, and let's call this equation 2. So now if you observe carefully, you have two linear equations in A and D. A plus 5D equal to 12 and A plus 7D equal to 22. So all we need to do is now solve this pair of equations, and we can do this using elimination. We can subtract the 2 equations and the A on the LHS will get eliminated. So I'm going to do by 2 minus 1, and what will that do? So on the LHS, the A terms will get cancelled out, and I will have 7D minus 5D, that's 2D, and on the right side I will have 22 minus 12, that's 10, and this gives me D equal to 5. So the common difference of the AP is 5, and now if I plug this value of D into, let's say, the first equation, I get A plus 5D. So 5D is 25 because D is 5. So A plus 25 is equal to 12, and this means that A is equal to 12 minus 25 or minus 13. So the first term is minus 13 and the common difference is 5. And now it's very easy to write the first 3 terms of the AP. So the first term is minus 13. The second term is minus 13 plus the common difference 5. So that's minus 8. And the third term is minus 8 plus 5 again. So that's minus 3, and so on. This AP continues. So the first 3 terms of the AP are minus 13, minus 8 and minus 3. Okay, in question 19, the problem statement is Subba Rao started work in 1995 at an annual salary of rupees 5,000 and received an increment of rupees 200 each year. So increment is a raise, an increase. For example, if his initial salary was 5,000, the next year his salary would be 5,000 plus 200 or 5,200. Now the question says, in which year did his income reach rupees 7,000? So his original salary is rupees 5,000 and his eventual salary in the question is rupees 7,000, and he gets an increment of rupees 200 every year. So we have to find out in which year does this happen. Now this is a very straightforward question, and in fact you can solve it almost mentally. You just have to see that from rupees 5,000 to rupees 7,000 is an increment of plus rupees 2,000, and he gets an increment of plus rupees 200 every year. So the total increment is 2,000. The increment per year is rupees 200. So this means that the number of years it will take to get this increment of 2,000 is rupees 2,000 divided by rupees 200, or 10 years. 200 per year, so 10 years. Yeah, so it will take him 10 years to get a total increment of 2,000. So his annual salary will go from 5,000 to 7,000, and 10 years post 1995 is 2005. So in the year 2005 his income will reach rupees 7,000 per annum. But now let's rephrase the solution in terms of arithmetic progressions. So if you think about it, the salary per annum for every year will make an arithmetic progression. How? Well, the initial salary is rupees 5,000. The salary the next year will be rupees 5,200. The salary the year after will be rupees 5,400, and so on. So every year there will be an increase of rupees 200, and the eventual salary will be rupees 7,000. So in terms of arithmetic progressions, this is the first term. So A is 5,000, and the common difference is the increment of 200 every year. So we have an increment of 200 every year. So the common difference is 200, and the end term or the nth term Tn is 7,000. So now let's find the value of n. So we have Tn is equal to A plus n minus 1d, the formula to find the nth term of any AP. Now let's plug in the values. So Tn is 7,000, the first term A is 5,000, and then we have n minus 1 times d. So we have d is 200, so 200 times n minus 1. So now this gives us 200 times n minus 1 is equal to 7,000 minus 5,000, so that's 2,000. And now let's divide by 200 on both sides, so we get n minus 1 is equal to 10, or n is equal to 11. So 7,000 is the 11th term of this AP. So 7,000 is the 11th term of this AP, and 5,000 is the first term of this AP. So 5,000 corresponds to the year 1995, and to go from 5,000 to 7,000 in the AP, we need to make 10 jumps, because the 7,000 is the 11th term. So we need to make 10 jumps, and that means that the number of years elapsed to go from 5,000 to 7,000 is n minus 1, or 10. So it will take Subba Rao 10 years to get from a salary of rupees 5,000 to rupees 7,000. Now I want to stress upon one point. Like when we calculated the answer in the beginning, it was fairly straightforward. We saw that the total increment is 2,000, the increment per year is 200, and hence it will take 10 years to get this total increment of 2,000, and that means that 10 years after 1995, or in the year 2005, the salary will reach rupees 7,000. But in this AP approach, I have seen some students make this mistake, that when they get n equal to 11, they add this 11 to 1995. So they get the answer as 1995 plus 11, or 2006. But actually as I told you, to go from this first term to this last term, how many jumps do you need to make? Because every jump represents 1 year. So to go from 5000 to 5200, you need to make one jump, or 1 year, a time of 1 year. To go from 5200 to 5400, and there's another year, and so on. So to go up to 7000, there is 10 jumps or 10 years. So the answer is n minus 1, not n. So make sure that you understand this minor point carefully. So the correct answer is obtained by adding n minus 1 to the initial year 1995. So the correct answer is 1995 plus 10, which is 2005, and not 1995 plus 11, which is 2006. So make sure that you understand this minor point carefully. Question 20 of this exercise is kind of similar to the last question of the same exercise. The problem statement says Ramkali saved ₹5 in the first week of a year and then increased her weekly savings by ₹1.75. If in the nth week her weekly savings become ₹20.75, find n. So the weekly savings in the first week are ₹5. In the second week, the weekly savings will be 1.75 more than this, so it will be 6.75. In the third week, it will be 1.75 more than this, so it will be ₹8.50, and so on. So we have to find at what week number does the weekly saving number reach ₹20.75. So very easy question. We can do it directly just using simple arithmetic, or we can phrase the solution in terms of in terms of arithmetic progressions also. So let's first do the direct arithmetic approach. So we have to go from ₹5 to ₹20.75, and this is a difference of plus ₹15.75, and every week the weekly savings increase by ₹1.75. So ₹1.75 per week is the increase in savings that happens every week. So total increase is ₹15.75. Increase per week is ₹1.75. So we just take the ratio of these two numbers and we get the ratio as 9. So it will take 9 additional weeks to go from ₹5 weekly savings to ₹20.75 weekly savings. Now this is week 1. ₹5 corresponds to week 1. So, and because there are now 9 weeks after the first week, then the week of ₹20.75 will be 9 plus 1, or week number 10. So make sure that you understand this point carefully. Because ₹5 corresponds to the first week, and there are 9 weeks that succeed the first week, after which the saving hits ₹20.75. So the week number, or the index of the week in which the savings become ₹20.75 is 10. 9 plus 1, or 10. Now let's do the same thing. Let's rephrase the solution in terms of arithmetic progressions. So we have the first term a is equal to 5. The common difference is the increase in weekly savings every week, which is 1.75, and the last term is 20.75. So Tn is 20.75, and now let's apply the relationship for Tn in terms of a and d. So Tn is a plus n minus 1d. So let's plug in the values. So Tn is 20.75, a is 5 plus n minus 1 d, and d, let's plug in the value for d also, is n minus 1 into 1.75. So if I subtract this 5 from 20.75, I get 15.75, and this is equal to 1.75 into n minus 1. And now let's divide by 1.75 on both sides. So we get n minus 1 equal to 15.75 by 1.75, that is equal to 9. So n minus 1 is 9, and this means n is 1 plus 9, or 10. So in this AP that we wrote for weekly savings every week, the term 20.75 comes at index 10. And this means, as we saw earlier, that in week number 10, the weekly savings will become rupees 20.75. So make sure that you understand the difference between this 9 and this 10. So 9 weeks is the difference or the time elapsed between the savings of rupees 5 and rupees 20.75. So it takes 9 weeks for savings to go up by this much amount, 15.75. But the index of the week in which the savings become 20.75 is 10. The index of that week is 10. So the answer to this question is n is equal to 10.
Hi, so in this video we are going to find the sum of arithmetical progression, right? So as we have seen in our earlier videos that any arithmetic progression can be written as A, where A is the first term, and the second term will be written as A plus D, where this D is the common difference, right? And A is the first term. And the third term will be written as second term plus D, that will be A plus 2D, right? And fourth term will be A plus 3D, and this will continue till nth term, which will be A plus n minus 1D, right? And n minus first term will be A plus n minus 2D, right? So this is a series with n terms, where first term is A and the last term is A plus n minus 1D, right? So one way of writing this series is this. Another way, where if I write this last term as L, this series can be written as A plus D, A plus 2D, A plus 3D, and this will be last term, and this term can be written as last term minus D, right? Yes. In the last video we have found the formula to find the last term, where I have written this term as the nth term, right? And since this series has only n terms, this last term can be called as L, right? Can be denoted as L also, which represent the last term. Okay. And what we have to do now? Yes, we are planning to find the sum of this series. So if I write S as the sum of this series, it can be written as S equal to A plus D plus A plus 2D plus A plus 3D plus L minus D plus L, last term and its previous term. So this will be the sum of this series, right? And if I write this series in opposite order, nothing is going to change. The sum is going to remain same, and only the order of the term is going to change. That means if I write in opposite order, I have to write this L first over here, then I have to write this L minus D, right? And its previous term will come over here, and that will be L minus 2D, right? And L minus 2D's previous term will be L minus 3D. This will be the series in descending order, right? And this will continue till the last term will become the first term, which is A, and the last but one term will be A plus D, right? And what is this? This will also be equal to S, because we haven't changed anything. We have just changed the order of writing, isn't it? So this will also become S. And let me call it as equation number 1 and this as equation number 2, right? And if I add both the equations, left side will become S plus S, that is 2S. This will be equal to, if I group these terms, these are the first terms of two series, these are the second terms, right? These are the third terms of the series, and these are the fourth terms of the series, and these are the second last terms of the series, and these are the last terms of the series. Now one magic is going to happen over here. What is going to happen is, if I add these groups, some of these groups are going to be same. What is the first group? First group is a plus l. If I add the first group, I'll get a plus l, right? And if I add the second group, again I'm going to get a plus l, right? This plus d and minus d will get cancelled, and we will get a plus l from here, right? And similarly from the third terms, or the third group of terms, again we are going to get a plus l. Plus 2d and minus 2d will get cancelled, right? And from here also I'll get a plus l, but I'm not writing that. And if I talk about these last terms, here also we are getting a plus l and a plus l, right? So how many total a plus l do we have? Yes, originally we had n terms in the series. So by flipping also we are going to get n terms, and then we are adding two terms each. So I'll get total n a plus l. So 2s is equal to n multiplied by a plus l. Or you can say s is equal to n multiplied by a plus l by 2, right? So this is the one formula to find the sum of arithmetic progression. But here we can substitute this l by this last term. By doing that, we'll get another formula. So this can be written as n multiplied by a, and l can be written as a plus n minus 1d. So this will be a plus n minus 1d, right? Let me convert this also into square brackets, and then we have 2 in denominator. So this will become n multiplied by a plus a is 2a plus n minus 1d divided by 2. So these are the two formulas of finding sum. Let me write them properly. The first formula is s equal to n multiplied by a plus l by 2, and the second formula is s equal to n multiplied by 2a plus n minus 1 multiplied by d divided by 2. So this is one method of finding the sum of an arithmetic progression.
Thank you for watching our channel. This video உங்களுக்கு பிடிச்சிருந்ததுனா கமெண்ட் பண்ணுங்க, லைக் பண்ணுங்க, ஷேர் பண்ணுங்க. மறக்காம இந்த சேனலை சப்ஸ்கிரைப் பண்ணிட்டு பக்கத்துல இருக்கக்கூடிய பெல் பட்டனை ட்ரைன்